Welcome to this video. This is covering the physics topic in combined science on describing waves. It's an introductory topic for year 9s in our school, but it covers all the GCSE content necessary for describing waves. So we will start by looking at some key learning questions. The first question is, what do waves transfer? How can we describe waves? And what is the difference between longitudinal and transverse waves? First of all, waves, earthquakes. This was the earthquake that took place in 2004, the famous tsunami, which created massive, widespread destruction in the Indian Ocean, and it resulted in loss of a lot of lives. So this is what waves can do. Another example is the earthquake in Pakistan in October 2005, which resulted in the death of 80,000 people. And these are some of the pictures you can see from the devastation caused by earthquake. And earthquakes are also waves. So this is to give you an idea of what waves can do. San Francisco in 1906, the Durdle Dorset. We'll just look at the arch here. This is created by water waves hitting the rock. And it's created an arch there. So waves transfer energy and information. That's the first question for you. That's the first question answered. Waves transfer energy and information. Please remember this. Next, how does light travel? Question for you. Light is a wave. And do you know any other types of waves? So, types of waves. Earthquakes produce seismic waves which travel through the earth. Another type of waves is electromagnetic waves like radio, light, microwaves used for weather, for mobile phones. And you can see the GIF here, how earthquake waves are traveling through the earth and causing devastation. And also you can see how a light wave travels in a what we call a transverse movement, and we will look at what transverse means a bit later. Okay, here's a waveform. You've got to be able to describe this waveform. This line here shows rest position. So a wave like a string or like a skipping rope, up, nice shape of the wave. This height here is your amplitude. This difference between these two peaks here is a wavelength. Also, this difference between these two troughs, is also a wavelength. So the crest is the peak and the trough is the peak in the opposite direction. You can see a duck dancing up and down on a wave in water, and energy is moving in the direction shown by the arrow. Next, some key definitions. You must learn these definitions. Amplitude is the height of a distance. So as I said in the previous slide, from this dotted line is rest position. The height a wave moves is the amplitude. So it's basically the height of a distance of a wave moves from a point from its rest position. It's measured in meters. The greater the amplitude, the louder the sound. Next, wavelength, distance between two corresponding points, and you can see now between these two crests or peaks, between two troughs, and between 2 points here, half of the wave there, half there, that's one wavelength. Remember, this sign is like an upside down Y, it's called lambda, Wavelength is also measured in meters. Next, frequency. This is the number of waves which pass a point every second, and it is measured in hertz. So it is measured in hertz. Hz is the sign, capital H, little z. And lastly, period. This is the length of time it takes one wave to pass a point. The way we measure it, a period equals 1 divided by f. So period t equals 1 divided by f. So if frequency was 10 hertz, then time period is 1/10. Please remember the formula. Next, changes in frequency, wavelength, or amplitude of a wave can be used to transfer information from one place to another. Example, when you listen to radio, the music is sent by variations in the frequency of the radio waves. Questions won't give you the answers. Suggest how you can see light, how we see light, change when the amplitude of light waves varies. What is frequency? What is time period when waves pass a point every 2 seconds? And write 2 things that the waves transfer and give an example of each. So for my class, there will be a accompanying worksheet with this where you can answer the questions. And also you can pause the screen here and you can answer the questions in the on this slide and just fill in the gaps to check your understanding. Okay, and the answers are on the slide. And bit harder questions. Look at the following waves. For each wave, write down the wavelength. Again, I'm going to quickly whiz through this. Please pause the slide. Do have a go at these questions to cement your understanding. And here are the answers. I'm going through these quickly. There are 2 main types of waves: longitudinal waves and transverse waves. Sound is longitudinal, light is transverse. Transverse waves, definition important, it's when a particle moves at right angles. The particles move at right angles to the direction the wave travels. So what we're saying is the particles moving up and down and the wave is traveling in this direction to the right. That's known as transverse waves. And you can see this in the GIF at the bottom here. Next one, longitudinal wave. Again, learn the definition. This is where particles move back and forth parallel to the direction of wave travel. And you can see it here in the bottom GIF that the wave is moving in this direction with the arrow and the particles are moving like this. If I put the arrow there, you can see the movement of particles. Okay. Explain how slinky movement describes a particular type of wave. And if you were to describe a transverse wave, you will just say the particles are moving at right angles to the direction of wave travel. And for longitudinal, the particles are moving parallel to the direction of wave travel. Let's look at some types of waves. Sound is longitudinal. Light is transverse. P waves is longitudinal. P waves are type of earthquake waves, seismic waves. There are 2 types, S and P. Water transverse, S waves are transverse, S for transverse. Here's how you remember it. S waves, transverse has S in it, so they are both transverse waves. Ultrasound is sound, so sound is longitudinal. Ultraviolet is electromagnetic wave, so it's transverse. And here are some of the questions. You can pause the slide to attempt these questions in your own time. And then finally, there is an exam style question. Compare and contrast the way particles move in a sound wave and in a wave on the surface of water. Please pause the video here and answer this question in your own time. And that is the end of presentation. Thank you for watching.